Okay, so this tour that I started on sort of the second day of class is finally ending. Okay, I wanted to sort of give you guys a gist for what's going to happen. Okay, and I want to tell you about the projects. The projects would not work. I could not explain the projects if I didn't have a certain vocabulary, and I've introduced a vocabulary, and I wanted to give you an idea of what the project would also do. Okay, so we've seen the first implementation, that you're doing basic functions in a Lisp interpreter. And what do you think, if you want to finish a Lisp interpreter, what's the second assignment going to be? What's left from what you, those of you who understand Lisp enough? What can't you do right now? You can't write your own functions. Okay? So that's what will happen next. And you know, the whole, conceptually that might be harder, they're all equally hard. I mean, the two of them equally hard, but the sort of the growing pains you would have gotten over. Okay, and then what do we do? Okay, so I talked about eager and lazy evaluation, and that's something that, so you know, we want to go beyond what Lisp interpreter does, what C Lisp does. Okay, that would be a cool boasting point, bragging point. So we'll do lazy and eager evaluation in the Lisp interpreter. And that's where we'll get into concurrency for eager evaluation. And with lazy evaluation, so one of the reasons why, you know, lots of reasons why the code base is changing is because A, we kind of don't know what we are doing either, right? There's no standard on how to implement Lisp interpreters, especially extendable Lisp interpreters, which is what we want. So, oh, we need this extra variable, we need an environment, you know. So what will happen in lazy evaluation is that you won't be using a global scope. You'll be having your own scope. We'll see what that means. So that's what we'll do. And given these projects, how can I introduce distributed computing into this? What kind of distributed project would make sense to build on this? Lisp server, invoked from a Java client. And what about a bash client? Imagine your bash client also becomes a Lisp interpreter. You begin something with a parenthesis, it starts computing Lisp. Okay? And otherwise it does the bash command. Okay, so there's a whole area of research which I was very excited by when I was a grad student. So here I am teaching a course on multiple languages, right? What I got really turned on by was the paper called Towards a Monolingual Environment. I think I'm one of the few people who's ever read that paper. And I'm one of the few people who try to build on this because I got an email message as a grad student from the author, and I was so pleased. So that said that, look, if you are in a practical system, you need to deal with the debugging language. You need to deal with a command language, and you need to deal with a one programming language, whether it's C or Pascal or whatever at that time. Couldn't we go and combine all of these things into one? Okay. And Robert mentioned at the start of the class, hey, why aren't you doing more small talk? About the same time I was learning small talk, and small talk had that system. The small talk programming language was also the small talk shell language, if you will. So we aren't going to quite do that. You're going to have the bash syntax and the Lisp syntax. But it's only one, still it's one tool, right? That's something. So that's what will happen here. The bash code you will write will be copy and paste of what I just showed you. Okay, you don't understand all that stuff? Fine, neither do I. But it's basically going to just send a message to the Lisp interpreter and get a result back and show it. Okay. What will be interesting is the Lisp server, the Java server, okay, and the client will also be very similar. The Java server will have to, this will be multi-threaded. So my server can be, so you can define a function that Ben can use later, okay, so we can, since it's a client-server interaction, you can imagine doing programming together on that. Okay, so that's a big deal. It's not going to be a kind of monolingual system, mono-user interface, but also it's a distributed collaborative Lisp interpreter. Okay, so it's adding up. So that's what we're going to do here. Okay, so you'll have to combine threads and the kind of pattern you will use here will be sort of a pattern you will use almost in any application you write. When we do distributed computing, we look at things that are faster than sockets, and more high level. But this is sort of the basic thing that you will learn. If you've done 431, if you've done internet protocols, there also you write a client and server, but the client, I think it might be a similar. You don't write the server there, right? You just write the client. Here you write the server too. So to that extent, you'll learn something different. So those are the regular projects. Now the question is, what other projects can I give you? Okay, and we'll also do a lazy list. And this is planned. Okay, who knows what's really going to happen? Okay, but hopefully this will all happen. Okay, and I have ideas about all of them. But the extra credit part may or may not come. You know, who knows how short-handed we will be? Who knows how much time things will take? So I think the server client one will be the easiest project. It's coming at the end, which is just as well. And the eager and lazy evaluation will also be fairly simple if we've structured things properly. Conceptually, it will be hard. So to understand the concepts, it will be hard. The algorithm used might be a little tricky and lazy, but the implementation will be just a few lines of code. Okay. We'll continue the interpreter theme, but you'll write a Prolog interpreter in ML, and I have ideas how to do that also. Okay. So that will cover Prolog and ML, which is the two other things that we are looking in depth. And then it would be nice if you also get a machine learning project. Okay. And so what we'll do, and again this is planned, you know. So we can learn things about images and we can learn things about, you know, grades, but that's nothing to do with programming. So if you're learning something, you might as well learn something having to do with programming. So we'll try to figure out through machine learning whether the programmer is facing difficulty or not. Okay. That will be, and we're not going to write machine learning algorithms. Just as the example showed, we're going to use an API to a machine language system, and we're going to figure out what the features are. And that will be we're not even going to figure out what the features are. We're going to use the features and try to understand how they work. Okay. So some exposure to machine learning, and again, this is optional. You don't want to do it, don't do it. But you know, this is within the scope of the material you'll cover in class. So just, you know, I want to give you guys a chance to explore that in an assignment. Okay. So let me talk about, this is the part that you probably, you know, if you look up the definition of Prolog, you'll understand how it works, and I've already talked about Prolog. So the other projects, you can get an idea of how, what they're supposed to do at least, if not how. But let's talk about difficulty detection. Why might a system want to infer whether some programmer is in difficulty? I mean, we understand whether the system is trying to detect whether somebody's got some disease or whether the stock market is going to change. You know, we make money or we live one way. Whereas here, what do we gain by figuring out whether some programmer is in difficulty or not? By machine somehow learning, if we could do it right. Perhaps.
Maybe if you were working in like an agile development thing, that you could adjust like the amount of hours that task is supposed to take accordingly.
Okay, so if somebody's, you know, there's a lot of you're talking agile situation where, or in any situation, one of the big deals is, you know, can you project when the project will finish? And if you don't know whether a programmer is facing difficulty, you may not know. And in agile situation, actually, there's a greater chance that you would know whether somebody is difficulty because you probably have meetings every day. Okay? But if you outsourced it to some other country, and that country, those people are too polite to go and ever say that they're facing difficulty, and that is true, okay, in some cultures, you're just surprised. Okay? So that would be good. Okay, you can delay, and that's not one of the things I put down in my list. Next, so that's certainly good, and Other reasons?
I've seen a couple of projects that use machine learning to do static analysis, so for code reviews.
For code reviews? So what do they do?
The one that I'm really familiar with was developed in Facebook, and it was as a simple start, just null pointer errors for Java. And so it was anytime you dereference something, if you didn't check for null, there was this sort of implicit code review that they learned from previous code reviews.
So I like that. Okay, so it's kind of a recommender system, which is saying that based on what we've seen before, we are going to warn you about, and we're going to learn that part. Okay. Other. Yeah, Ben.
Sometimes it's easy to get stuck on one problem for a really long time and you don't realize how long you've been looking at it.
So if the system tells you, hey, you're stuck, don't bother with as list anymore. Go on to the next step. Okay, the assignment is due on Tuesday, and you're just stuck there. So for self-introspection, okay, or afterwards, when you say, hey, postpone the assignment, I say, what took you time? So here's some evidence. I got stuck here. That's because you changed the definition of as list. Okay, so that could be the case. Other reasons? Could I benefit from knowing whether you guys are in difficulty? If I'm a kind person? If I'm a masochist, I would say, yeah, good. But otherwise, I would say, hey, I screwed up somewhere. Okay, let's postpone, let's give more help. Okay, so and even more than that, you guys don't even think of the situation. So when you have a difficulty, you go and post a message if you're brave, or you come to office hours. Also, if you're not shy, and some of you might just continue working on without even. That's a common case. Programmers underestimate their problems. Okay, and so you might, if you're working in industry, get the help of somebody who wrote that module that's causing you problems. That was really their problem actually, or an instructor, and get help. And instructor, our job is to help anyway. But in industry, people have found. So if I help you in a team, in a teamwork, I'm stopped from working, right? My productivity goes down. Maybe yours goes up. What do you think happens to the overall team productivity? The helper's productivity goes down, the helpee's hopefully goes up. The overall team productivity, any guesses? Goes down. Shouldn't help other people. Actually, it goes up. Okay. So I mean, I can see going both ways. Who knows? Who knows what the right answer is? Who knows whether the papers I'm quoting are correct or not? You have to look at all research very skeptically. But the results show that it goes up. Okay. The more people provide help beyond the call of duty, okay, the more the team. And it basically you infect each other with your knowledge too, right? So the team benefits. Maybe you're no longer that special, but that's not what we're looking at. We're looking at team productivity. Okay, so review your pain points and solutions. So if you had trouble, you can go back before the exam and say, what really caused me problem? Oh, two-string as list caused me problem. Let me go and figure out, because we forget things very easily. Okay, after finals, we pretty much dump the whole cache away. But even between midterms and even between classes, sometimes we dump, cache clears. So before exam, what do you guys do? You go and refresh your cache. And you can say, well, let me see where I faced difficulties and how I overcame them. And so that if there's a problem in the exam, which is similar, I don't fail. This is my theory, okay? We don't know whether this is going to work out or not. So we can provide you with help, either automated help, as Ben mentioned, where, we do a sort of implicit code review and say, this is where this is a problem you're going to have. Or somebody, in fact, gets in touch with you. Inspection testing, if somebody's been facing difficulty, maybe there are, what do you think? There will be more bugs or fewer bugs? I don't know the answer. Nobody's figured this out. What do you guys think? If I know that you face a lot of difficulty writing your string as list, what are the chances that you'll pass the test cases? More or less, you think? Or Doesn't make a difference? So the intuitive answer is that if they were facing difficulty, they probably screwed up. But my theory is, can you think of a counter argument?
Say, you don't know how hard it really is to put in a solution. You think it's easier if you solve the problem.
You saw the problem, right? So if you didn't see the problem, you might have still had the problem. So I suspect the bugs will be fewer, actually. Okay. And my sort of feeling, an analogous situation is that most accidents occur when you're coming back home in familiar areas rather than in unfamiliar areas. And most errors occur not because you couldn't think hard enough, but because it was so easy, I believe, that your mind wandered. Okay? And so I feel it's the other way around. But who knows? I mean, there's all kinds of things we can do. Okay? And we can really change the task. I can give you more documents. So let me just show you, who knows, ... Let me show you an interaction. This is something we did. Here's what's happening. The person's programming away, and the system says you're making slow progress. It used to say, this is a system we've developed here. It used to say having difficulty. And when I started using it, I didn't like the word having difficulty. I'm supposed to never have difficulty. So the buck stops at me. So we just made it slow progress. Okay? And this message is communicated to somebody who's interested in your difficulties. Okay? And why you like that? You don't like that? So we are already short-handed, and just imagine getting all these messages. Okay, so this isn't a perfect world, and this could work in a small team. And we used this system in a CS1 class. The student who did this thing, he was teaching that class. This is a PhD project, and he used it for his class. Oh, there's a little typo here. The students didn't know whether he was actually on the computer or not, so he could ignore these messages. So that's how we managed the work. But this interaction that is from a lab experiment, and here the person really helped the other person, and we are seeing the thank you message in this lab experiment from that person. Okay. So this is something that our research group is doing, and we're the only ones doing it, actually. That's why I was curious what you guys thought. So now we are using data, and Facebook probably has lots of people programming, and they get lots of data, and they can log everything. This is really a small data problem, not a big data problem. And so what do you think will be good cues for facing difficulty? How would you know? What kind of, like null pointer exception, Ben mentioned. If somebody's getting null pointer exceptions, maybe they're having facing difficulty. What other cues can you use to figure out if somebody's facing difficulty or not?
A lot of edits of like the same few lines.
Editing the same few lines a lot, right? That means you're editing and then deleting and then editing and then deleting. It took us such a long time, but that turned out to be the key. Okay? But other things, so we're not even looking at the program. We're not looking at bugs. We're just looking at editor interactions. Okay? But other cues, yeah?
Like running the program a lot, but only small.
Doing a lot of runs. Okay? Null pointer exceptions, local checks problems. Okay? If you're using advanced constructs, if you figure out using recursion and you're a CS110 student, maybe that's tricky. If you're using the ternary operator, which may be a bug-prone operator, okay? So who knows? The program itself might give you cues. The test case data might give you cues. Programming environment commands, whether you're debugging a lot, single-stepping a lot. Web accesses. So web is supposed to solve our problem, right? So more web accesses mean less difficulty. At least you knew what to search for, or could mean more difficulty. Both ways. So often what people do is, we've seen this in experiments. They go to Stack Overflow, they copy the code into your project, they get a lot of errors, and it takes them forever to figure out what they're doing. Okay? So just seeing the biggest paste that was done gives us a good cue. Okay? Anyway, so how do you, what project can you do? As I've mentioned, we have a system, we've had people use the system, so we have data. Okay? And the basic project will require you to look at the data that other people have collected, and the data is in two forms. The main form is the XML file, then CSV is some summary that you produce from. That XML file will tell you every exception you got, every edit you made, every file you opened, okay, what contents you read. So it's got almost everything you might want, and we're changing it as we speak. Then just for self-introspection, you can go and figure out what the algorithm is doing also. You can run the algorithm while collecting data. And this is telling us that, look, we break the stuff into segments. And for each segment, we go and make a prediction. And if there are enough segments with predictions saying, yes, they're in difficulty, we say you're in difficulty. So you see here that it's always said no. But that's not the case. I often get these yes things. And it also tells you for each file, when you started editing it, how much time you spent on the file. So one of the things I'm always curious about is how much time did I spend on this? So that's an orthogonal thing that you get from this. And it'll also tell you, how many edits you made relative to other commands, how many debugs you made. So this is some summary data that you can read. And also we go and if you allow that, if somebody allows that, we also get Chrome accesses. So when I was doing this Prolog project, I knew Prolog at one time in my life, but I've forgotten everything about it. All syntax, everything. How do you input? How do you do rules? How do you do queries? So you see what web pages I went to. Okay, and then somebody else can look at this information, or I can look at it later and say, oh, this is the one that told me how to do Hello World in Prolog, or how to read something in Prolog. Okay, and we only log safe accesses. So if you're accessing Piazza or Stack Overflow or accessing the EDU site, we log that, and one can disable that. So we have commands and safe web accesses of subjects and perceived difficulty instances, and we have an algorithm, and you can go and vary some parameters of the algorithm to go and see how it works, so that you get some feeling of, and you can go and execute that algorithm using Veka. So you get some experience. You can say, you can get some experience with machine learning. That's sort of my goal here. That you learn something you haven't learned before. That's practical. But you can, and I mentioned all that data before, if you want to, and this is not going to get you any credit, run the system yourself, collect your own data, go and indicate when you're having difficulties, and see how well. So the algorithm that we have there's a family of algorithms, and they're tunable, and you can in fact go and tune and choose the algorithm. It needs a little bit of documentation. So you can in fact run this throughout the course and mark your difficulties, and try to go, when you go into your experimentation, you can add your data to the set of data we give you, okay? So that's something I just want to mention. The reason I'm spending all this time here is because if you want to exercise that option, that will exist. And why? So then you become a study subject, and why not take part? Why take part in the study? You're just as those poor Facebook programmers who had null pointer exceptions. Their exceptions help other people. Just pure altruism. You can try to figure out yourself, what you were doing. So since we log everything, everything is saved. So you can roll back your code to any point and say, what did I do last Monday when my as list was working? Okay, and it's in the log. It's not in a very, you can find it, and we'll try to use an interface to make that easier. And then you can get better insights into how this algorithm works. You can just tune the algorithm, see how it's working. And why not? Well, you have to go and install a plugin, which is actually one click. You'll get some false positives and false negatives, and ideally you should correct them. You don't have to, but that might just annoy you. So those are the reasons not to. So I just want to give these reasons here. Send me a Piazza private post if you want to study, if you want to take part. If even one person says yes, I'll just come up with the documentation for it. Otherwise, like I said, we have data for the assignment. We have the data to do it. Okay. So we are running out of time. So these are the overviewed concepts, and we looked at the projects also. So I got one message from somebody who was, I think, facing difficulty, saying, hey, I'd rather be writing Lisp code than, so I want to address that issue in the last two, than writing an interpreters. Okay? Everything in life has pros and cons. So in the 2-3 minutes, somebody want to go give the pros of, so why am I writing a Lisp interpreter in Java? I don't learn a new language. Why not write some programs in Lisp where I'm learning a new language? So the pro is I'm learning a new language. Okay. Any other pro in sort of going the, yeah?
You're learning the structure and design of the language, which in most cases is more important than just being able to write a program. I think we do more than that.
Thank you, Nick. So you're learning the design of the language. So my feeling is you don't really know how to program if you don't know how the programming language constructs work. Okay? You don't know how the programming language constructs work if you don't know how to implement them. Okay? I've seen many people, we've tried to interview many faculty members we're teaching, and they say, here I am programming away, watch me program, and maybe and hopefully you're learning something. That's like my saying, hey, you want to become Roger Federer or Nadal, just watch their match, and you'll become them. And there's some truth there, you know, after watching a good, there's studies that show that after watching a US Open, people start playing better tennis. But that's not the same as having an expensive coach, who's John McEnroe or somebody else, who's telling you what a lob is and when to use a lob and when to use a drop and when to slice it when the other person's getting every shot in the world. So that's one thing. You know, when I first started the class, somebody said, I just want to get a job better. I want to increase the chances of my getting a job. And a lot of people teach CS 110 courses in Scheme and Lisp. Okay? If I was to ask you to program in Lisp, you would be no better than those CS 110 students. Okay? You would have learned the same concepts, different concepts, maybe learned recursion, but the same concepts. So the big criticism I got from students in the previous 524s was it was too easy. That's why I said, you know, I'm glad this is hard. It may be too hard, but at least not too easy. And you know, we'll provide you with help, you know, to get it all done. So, so that's the argument for doing these interpreters. And you are going to, in your test cases, program in Lisp. And we will see Lisp solutions later too. So I guess I'm out of time. But the next slide actually goes and tells us where we're going to go next. And we'll do that